Picture a star so hot it defies imagination. A blazing inferno 35 times hotter than the sun, burning at a staggering 210,000 Kelvin. This is WR102, the hottest star we've ever discovered, a cosmic furnace teetering on the edge of annihilation. Located 9,800 light-years away in the constellation Sagittarius, it's not just its heat that captivates us, it's the story it tells. How can a star reach such extremes? What forces sculpted this fiery titan, and why is it racing toward a spectacular end? WR102 isn't your average star. It's a rare Wolf-Rayet star, one of only a handful in our Milky Way, shedding its outer layers in violent stellar winds and glowing with a luminosity hundreds of thousands of times greater than our sun. Scientists say it's just 1,500 years from exploding as a supernova, a blink in cosmic time. This documentary will take you on a journey through its fiery past, its dazzling present, and its explosive future. We'll uncover the secrets of this stellar marvel and ask, what does WR102 reveal about the life and death of the universe's most extreme stars? Buckle up. This is a tale of heat, power, and cosmic destiny. To grasp the enigma of WR102, we need to step back to the 19th century when the seeds of its discovery were sown. It was 1867 at the Paris Observatory when astronomers Charles Wolf and Wolf-Rayet peered through a 15-inch telescope and spotted something extraordinary. They observed stars with unusual spectral lines, broad, bright bands of light unlike anything seen before. These were the first Wolf-Rayet stars, named after their discoverers, a class of massive, evolved stars that baffled science. Little did they know, over a century later, one of these would claim the title of the hottest star known. Fast forward to 1971. Astronomers studying the Sagittarius region stumbled upon a peculiar star linked to an X-ray source called GX3+1. At first, they thought it might be related, but closer inspection revealed a standalone marvel, WR102. Its spectrum showed highly ionized oxygen lines, a rarity even among Wolf-Rayet stars, earning it the WO2 classification. This wasn't just another star, it was a cosmic outlier. By 1981, faint nebulosity was detected around it, a bubble of gas blown by its ferocious winds, hinting at its violent nature. The backdrop to WR102's story is the turbulent history of stellar astronomy. In the early 20th century, the Hertzsprung-Russell diagram revolutionized our understanding of stars, plotting their temperature against brightness. Wolf-Rayet stars like WR102 stood apart. Massive, hot, and short-lived. Born from the OB Association Sagittarius OB5, a stellar nursery of giant stars, WR102 likely started as a behemoth 40 times the sun's mass. Over millions of years, it burned through its fuel at a breakneck pace, shedding hydrogen and helium to reveal a scorching core. Astrophysicist Dr. John Hillier notes, Wolf-Rayet stars are the rock stars of the cosmos, brilliant, brief, and destined to go out with a bang. WR102's discovery built on this legacy, a testament to human curiosity and the relentless march of science. Let's dive into the blazing heart of WR102's story, unraveling its life through three defining acts: its birth and evolution, its extreme properties, and its imminent demise. Act 1. A Star is Born. WR102 didn't start as the hottest star. It earned that title through a brutal evolutionary journey. Born millions of years ago in the Sagittarius OB5 cluster, it emerged as a massive O-type star, perhaps 40 to 50 times the sun's mass. These giants burn hot and fast, fusing hydrogen into helium in their cores. But WR102's story took a dramatic turn as it aged. After exhausting its hydrogen, it swelled into a red supergiant, then began shedding its outer layers. Stellar winds, gusts reaching 5,000 kilometers per second, stripped away hydrogen and helium, exposing a core rich in heavier elements like carbon, nitrogen, and oxygen. This transformation marks it as a Wolf-Rayet star, a phase only the most massive stars achieve. Dr. Emily Levesque, a stellar astrophysicist, explains it's like peeling an onion. Each layer reveals a hotter, denser interior. Act 2. The hottest star unveiled. Today, WR-102 reigns as a WO2 Wolf-Rayet star, a rare subtype with oxygen dominating its spectrum. Its surface temperature of 210,000 Kelvin dwarfs the Sun's 5,778 Kelvin, making it 35 times hotter. To put that in perspective, if the Sun were a candle, WR-102 would be a blowtorch. Its luminosity is staggering, up to 380,000 times out of the Sun. Yet it's tiny, with a radius just half our star's. How does it pack so much punch? The answer lies in its density and fusion. With a mass of 16 solar masses, it's fusing helium and beyond, racing through heavier elements at an insane rate. Its stellar winds, losing 10 solar masses per year, sculpt a glowing nebula around it, a cosmic signature of its power. Compare that to the Sun's meek solar wind, losing just 10 superscript 1 solar masses annually. Astrophotographer Rafael Sampaio, who captured WR-102's nebula, says it's a faint dot in a dense star field, but its influence is breathtaking. Act 3. Countdown to catastrophe. WR-102's brilliance comes at a cost. It's dying. Having burned through most of its fuel, it's in the final stages of nuclear fusion, likely past helium burning and into carbon or oxygen fusion. This phase lasts mere thousands of years, a fleeting moment for a star. Calculations suggest it has just 1,500 years left before it explodes as a supernova, a detonation so powerful it could outshine entire galaxies for weeks. Will it trigger a gamma-ray burst, a deadly beam of energy? That depends on its rotation, which remains uncertain. Early estimates pegged its wind rotation at 1,000 kilometers per second, but newer data hints it's slower. Dr. Paul Crowther warns, if it spins fast enough, WR-102 could unleash a GRB, one of the universe's most violent events. Its end will scatter heavy elements across space, seeding future stars and planets. WR-102's life is a cosmic sprint to an explosive finish, a tale of extremes culminating in a grand finale. In 2025, WR-102 remains a celestial enigma, quietly blazing in Sagittarius as astronomers watch its final act unfold. Located 9,800 light-years away, it's too faint to see with the naked eye, but advanced telescopes like the Hubble and James Webb Space Telescope have brought its story into focus. Recent observations confirm its temperature at 210,000 Kelvin and its luminosity at 380,000 solar units, solidifying its status as the hottest known star. The nebula around it, captured in stunning infrared by the WISE and Spitzer telescopes, glows with ionized gas, a testament to its relentless stellar winds. Yet, studying WR-102 isn't easy. Its dense star field obscures details, challenging even the sharpest instruments. Astrophysicist Dr. Judy Schmidt notes, it's like finding a needle in a haystack, except the needle's on fire. Current research focuses on its mass loss and rotation speed, critical clues to its supernova fate. Is it spinning fast enough for a gamma-ray burst, or will it merely explode into a supernova? The answers elude us, but the clock is ticking. Only 1,500 years remain, a deadline set long before humanity existed. Today, WR-102 stands as a living laboratory, revealing how massive stars die and enrich the cosmos, even as its faint light challenges our technology and imagination. What lies ahead for WR-102? Its future is a fiery crossroads, with 3 potential fates on the horizon. Scenario 1. Supernova spectacle. In about 1,500 years, around the year 3,525, WR-102 will likely explode as a Type IC supernova. Having shed its hydrogen and helium, its core will collapse under gravity's crush, then rebound in a blast of light and energy. For weeks, it could shine brighter than the Milky Way, visible from Earth even in daylight. Dr. John Hillier predicts it'll be a cosmic fireworks show, scattering elements like oxygen and iron across space. These remnants will seed new stars and planets, continuing the cycle of creation. Scenario 2. Gamma ray burst. If WR102 rotates rapidly, its end could be far more dramatic. A gamma ray burst GRB, a focused beam of high-energy radiation, might erupt, one of the universe's most destructive events. If aimed at Earth, it could strip our atmosphere, though its distance, 9,800 light-years, makes that unlikely. Dr. Paul Crowther cautions, a GRB from WR102 would be rare, but not impossible. We just don't know its spin yet. This scenario would mark it as a cosmic wildcard, reshaping our view of stellar deaths. Scenario 3. Quiet fade. Less likely, WR102 could defy expectations. If its core lacks the mass or rotation for a supernova, it might collapse directly into a black hole with minimal fanfare. This failed supernova would leave a silent void, its heat and light snuffed out. Astronomer Dr. Emily Levesque muses, it'd be an anticlimax for such a fiery star, but nature loves surprises. Whatever happens, WR102's end will echo through the galaxy, a final chapter in its blazing saga, and a clue to the fate of other massive stars. WR102's story is a cosmic epic, a star born in a stellar nursery, forged into the hottest known beacon, and now poised for a cataclysmic end. From its discovery by Wolf-Rayet to its modern unveiling as a WO2 Wolf-Rayet marvel, it's taught us that even stars have life cycles of breathtaking extremes. At 210,000 Kelvin, it burns brighter and hotter than we can fathom, a fleeting giant with just 1,500 years left to shine. Its lessons linger. Massive stars like WR102 shape the universe, forging the elements in our bodies and the worlds we inhabit. As Dr. Judy Schmidt puts it, every atom in us once burned in a star like this. Will it explode in glory, unleash a gamma-ray burst, or fade into darkness? We may never witness its finale, but its light, traveling 9,800 years to reach us, connects us to that destiny. So, gaze at the night sky. Somewhere in Sagittarius, WR102 blazes, a reminder of nature's power and fragility. What other secrets hide among the stars? That's for us to explore, because in their stories, we find our own.